Welcome to World Decoder. Today we uncover a technology that moves faster than sound, transforming the very nature of aerial combat. In the realm of modern air warfare, speed is the ultimate god, dictating survival and dominance in the unforgiving skies above. The fastest missiles known to man can only reach speeds of Mach 5 or 10, pushing the limits of physical propulsion. However, there exists something in the universe that travels tens of thousands of times faster than any missile: the speed of light. Imagine a terrifying scenario where an enemy launches a $1 million missile directly at you, leaving you with mere seconds to react. Traditionally, you would deploy decoys or perform desperate acrobatic maneuvers, hoping to escape the lethal grasp of the approaching heat seeker. Instead, your aircraft simply projects a concentrated beam of light, invisible to the naked eye, directly onto the incoming target's path. In a fraction of a second, the missile's casing melts away, compromising its structural integrity before it can even get close. The internal explosives trigger instantly, causing the weapon to detonate safely miles away, rendering the threat completely useless in an instant. This is not a scene from Star Wars or science fiction. This is the reality of the US Air Force SHIELD project. The Self-Protect High-Energy Laser Demonstrator is turning what was once pure fantasy into a tangible and terrifying military capability today. But why are superpowers so obsessed with laser weapons? The answer lies not just in power, but in the revolution of cost. Consider the Standard Missile. A single AIM-120 unit costs approximately $1 million, a heavy price for a single shot. Furthermore, a fighter jet can only carry a maximum of 4 to 6 of these heavy weapons before running out completely. Once those few missiles are fired, the pilot is defenseless and must retreat from the combat zone to reload and refuel. In stark contrast, a single shot from a high-energy laser weapon costs between $1 and $10 to generate and fire. That is roughly the price of a morning cup of coffee, making it an incredibly economical solution for destroying million-dollar threats. Laser weapons effectively possess an infinite magazine, limited only by the aircraft's fuel supply and the engine's ability to generate power. As long as the engine is running and providing electricity, the pilot can keep firing without worrying about running out of bullets. This represents a fundamental turning point in the economic game of war, shifting the advantage to those with efficient energy weapons. It eliminates the logistical nightmare of transporting heavy munitions across the globe, simplifying the supply chain for sustained military operations everywhere. With aerial refueling, a laser-equipped fighter could theoretically stay in the fight and maintain dominance for hours without ever landing. However, why do we not see lasers on every jet yet? The problem lies in the massive challenge of electrical power. To create a laser strong enough to melt steel from miles away, you need a colossal source of consistent energy generation. Legacy aircraft simply do not possess the electrical infrastructure required to support such demanding, high-energy weaponry in a combat scenario. This brings us back to the critical engine core upgrade we discussed previously, specifically designed to solve this massive energy deficit. The new generation of engines does more than push the aircraft. They act as flying power plants capable of immense output. They extract raw power directly from the turbine to run super high capacity generators, creating the juice needed for the weapon systems. This energy is stored in advanced supercapacitors, ready to be released in a microsecond burst to power the destructive laser beam. Without these monstrous engines, airborne laser weapons would remain nothing more than expensive science experiments confined to ground-based research laboratories. The challenge is not just generating power, but fitting that massive capability into a compact, lightweight package that can fly. Achieving high power density in such a confined space is one of the greatest engineering marvels of the 21st century. But lasers are not just for offense. Their most revolutionary application lies in the concept of active defense and invulnerability. Even stealth aircraft fear being locked onto by advanced surface-to-air missiles that can track them despite their radar-absorbing coating. With laser turrets mounted on the fuselage, a fighter jet can create a dome of protection, a literal shield of light. Imagine a scenario where multiple missiles are approaching from different directions, attempting to overwhelm the aircraft's traditional defensive countermeasures. Any missile that enters the kill zone is instantly scanned, tracked, and neutralized by the laser before it can impact. In this new era, the concept of stealth becomes less critical as the aircraft possesses an impenetrable armor made of pure energy. It transforms the aircraft from a fragile bird hiding in the dark into a flying fortress capable of swatting down threats. This requires sensors that can see in all directions simultaneously, reacting faster than any human pilot could ever hope to process. However, even the most advanced technology has a weakness. For lasers, there are specific Achilles heels that cannot be ignored. Weather is the primary enemy. Clouds, rain, and thick fog can scatter the light beam, drastically reducing its destructive power. In poor weather conditions, the lethal range of the weapon shrinks significantly, potentially leaving the aircraft vulnerable to attack. The second major challenge is heat. Generating a high-energy laser beam produces an immense amount of waste heat internally. Without a revolutionary cooling system, firing the weapon could cook the aircraft's own electronics and melt its internal components. The risk is real. If heat is not managed perfectly, the weapon meant to save the pilot could become their doom. Engineers are developing advanced thermal management materials to handle these extreme temperatures, ensuring the system remains safe and operational. Despite these challenges, laser weapons are moving out of the lab and onto the airframes of 6th-generation fighter jets. We are witnessing a historic transition where concentrated light is beginning to replace gunpowder as the primary instrument of aerial warfare. Future wars may no longer be defined by deafening explosions, but by silent, instantaneous confrontations decided at the speed of light. The speed and lethality of these engagements will be beyond human reaction time, governed by algorithms and directed energy systems. World Decoder poses a final question for this series. Will perfect weapons lead us to a state of permanent peace? If no one can successfully attack anyone else, could we finally achieve a stalemate that ends all major conflicts forever? Or will we simply enter a new, even more dangerous arms race, pushing technology to darker and more destructive limits? Thank you for joining me on this journey through our 5-part series decoding the secrets of modern fighter jet technology. Please hit that subscribe button to support World Decoder and ensure you do not miss our future explorations into technology. We have many more terrifying secrets and fascinating engineering marvels of humanity waiting to be decoded in our upcoming videos. Thank you for watching. This is World Decoder, signing off. Stay curious, stay informed, and we will see you next time. As the sun sets on the era of traditional ballistics, we look forward to a new dawn of technological innovation. Remember, behind every advanced machine and weapon system is the ingenuity and spirit of human engineering pushing the boundaries. It is the tireless work of thousands of scientists and engineers that makes these science fiction concepts a reality today. Vigilance is the price of safety, and technology provides the eyes and ears needed to guard the skies above us. Every breakthrough begins with a single experiment, a moment of discovery that changes the course of history for everyone. From the wind tunnel to the battlefield, perfection is pursued at every step to ensure superior performance and reliability. These technologies do not just change warfare, they reshape geopolitics and the balance of power among the world's nations. The future of flight is vertical, fast, and armed with light, redefining what is possible in aviation and defense. Connected by a global network of satellites, the modern fighter is never alone, but part of a vast system. In the digital age, lines of code are just as important as the physical armor and weapons of the aircraft. Ultimately, the decision to engage remains with the human operator, bearing the weight of responsibility for every action taken. Strength lies in unity and precision, as squadrons move as one entity to execute complex missions with absolute flawlessness. We hope that these advancements serve as a deterrent, preventing conflict rather than escalating the destruction of war. For the next generation, the sky is not a limit, but a canvas for dreams, innovation, and endless possibilities. Technologies developed for defense often find their way into civilian life, improving medicine, energy, and communication for all. From the edge of space, our planet looks fragile and unified, reminding us of the ultimate goal of protection. World Decoder is dedicated to bringing you these perspectives, bridging the gap between complex technology and your understanding. If you enjoyed this deep dive, please share it with friends who share your passion for technology and aviation. We love reading your thoughts and theories, so leave a comment below about what you want us to decode next. The complexity of these machines is a testament to human brilliance, a puzzle of millions of parts working together. As the mission ends, the pilot returns home, trusting in the technology that brought them back safely from danger. The light fades, the engines cool, but the relentless march of progress continues forward, never pausing for a moment. In the silence of the night, we prepare for tomorrow's challenges, armed with knowledge and the power of light. This has been a fascinating exploration into the future of combat. Thank you for spending your valuable time with us. Until we meet again for another decoding adventure, keep your eyes on the skies. This is World Decoder, out.